Now that we've learned how to interpret correlations between variables using a couple different plots, let's learn how I was able to create these plots in the first place. So let's move over to Alteryx and examine how we are able to create a workflow to build these correlation values between our different variables. Over in Alteryx, the first thing we're going to do is use an input data tool to go grab our data set. So we bring in an input data tool, go to the configuration menu, and hit the drop down menu and go to our churndata.yxdb file. The first thing I'm going to do is look at the preview menu to view what different fields and what does my data look like inside of this data set. So it looks like we have some information about each of the customers. So what state they're in, how long they've been a customer, phone number, area code, do they have an international plan or not, as well as some call history level. So aggregated up to the customer level. So things like how many total daytime calls do they have? How many total daytime minutes do they use the phone for? Evening, night, international, etc. And then at the far right-hand side, we have this churn field, and this is what we're trying to understand if they do churn, which is a true value, or they do not churn, which is a false value. So what I want to do now is I want to determine the correlation between our different variables. So between this churn field and all of these fields, and as well as these fields within each other. So to do this, we're going to use an association analysis tool, which is found inside of our data investigation category. So I bring in an association analysis tool, and there's three different configuration options and selections we need to make. The first one is deciding if we want to target a field for more detailed analysis. And in this example, we're trying to understand that churn field more. So yes, we do have a target field that we want to understand more about. So let's check on this. Then we state what that target field is, which is our churn field. Then over here, they asked us something about the target level of interest. This is going to be, do we want to understand more about the true or the falses or the yeses or the nos or the ones or the zeros? Don't focus on this too much. The only thing that this is going to mean is basically, do we want to have positive correlations with true values or negative correlations with true values? But don't focus on this part too much. The second main option that we have inside this association analysis tool is determining what fields and what variables do we want to possibly add to this model and to determine correlations of between each other and as well between the target variable and these potential predictor variables. And for our example, we're going to just simply select all for now. The third and last option is we have to choose what measure of association are we going to judge this correlation off of. Is it going to be Pearson, Spearman, or Hoefting? As you remember in the previous sections, I mentioned that we're only going to focus on Pearson for this example. So we'll just keep it at default as Pearson. The next thing I'm going to do is bring in a browse tool after the R or report output, and then another browse after the I or the interactive browse output. I'm now going to kick off this workflow, and then we can review the results next. Let me first grab that report output by maximizing this. Then I'm going to drag it over to our other screen. As you can see, these are the exact same results that we saw in the previous examples before, where we're trying to understand that churn field more, and then the level of association all these potential predictor variables have to that churn field. It's going in descending order. So at the top is the most associated variables with churn. So the number of customer service calls, then the total international minutes, then the international charge, etc. What we're also able to see is those p-values are the statistical significance that these variables have to that churn field. Simply, the more stars, the more statistically significant they are. And it looks like we have 5 variables that are statistically significant, and I would examine them more in the next section. So this is the report output that we saw before. Now let's go to that interactive browse. Inside this interactive browse, we have 2 different parts, like we saw before. We have a correlation matrix on the left-hand side and a scatter plot on the right-hand side. What we're looking for are those 3 things: very red marks for positive correlators, very little color for no correlation, and blue for negative correlation. So let me just select on 2 values against each other, which this shows has a 1.00 correlation between these 2 variables. And as we see on the right-hand side, the total night minutes and the total night charge. As you see, the value was 1.00, meaning they are perfect positive correlators within each other, as well as you can see on the scatter plot, as one moves, the other one moves directly in parallel with it. These 2 things, I would assume, are duplicate variables then, and we probably should include both within our model. The other thing that we can see are two variables that have very little correlation between each other. Like these two, for example, have a 0.03 correlation between each other, and it's the total day calls and the total international minutes. Since these are two potential predictor variables, we see that there's little to no correlation between them. Therefore, I can assume that these are safe to both use within that predictive model later. I'm able to determine that based off the very low correlation number here at 0.03, as well as in the scatter plot, I see no real trends within these two variables against each other. So this is an example of how you're able to develop a workflow to then view the correlation matrix, the scatter plots, and the report output to determine the correlations between your target variable and your potential predictor variables, and also examining if there's any inner correlation between your predictor variables.